Chapter 5, Part 1, Methods. Our goals for this chapter are to be able to implement methods, to become familiar with the concept of parameter passing, to develop strategies for decomposing complex tasks into simpler ones, to be able to determine the scope of a variable, and to learn how to think recursively. We are going to de-emphasize the recursion section because it is not part of our course objectives. Methods are, you could think of them as black boxes, and my favorite analogy is to think about a car. I don't know how an internal combustion engine works. I don't know how a hybrid engine works, and yet I am able to successfully drive a car. The way a car works is a black box to me. All I need to know is that I turn the key and it turns on, I press the gas pedal and it goes, I press the brake and it stops. I can turn the wheel and go left or turn the wheel the other way and go right. A method is very similar, and we've already been using methods in this class. And we're going to learn how to write them in this chapter. And we declare a method by defining a named block of code. For our purposes right now, we're always going to start with public static. The third thing you see there, void, is the return type. What is the data type that is being returned from this method? Whoops, and there is a typo. Square. So let me... Sorry, I got derailed. I'll keep going. Square is the name of the method, and int x is the parameter. It's the information we're sending to the method so it can do its job. Inside the method, that's inside the open and close curly brace, we set result. We create an integer variable called result, and we set it equal to x times x, the square of the parameter x times x. And then we return result. And here's where the problem is. When you have a return statement, that means that the method is returning a value. It's going back to where it was called. And in the method header, to the left of the method name, we have to put the data type of the value we're returning. So in this slide where it says void square, it should say int square because we are returning an int. Now, to call a method, we need to put the name of the method, and in this example we're using math.pow and then sending the arguments 2, 3. Math.pow returns something, so we have to put it on the right hand side of an equal sign because the value that's being returned will be stored in the variable on the left hand side of the equal sign. Sometimes we call those R values for right hand side and L values for left hand side. Some methods we've already used are math.pow, string.length, character.isDigit, scanner.nextInt, and the main method, which is the entry point to every Java application. Methods may have a capitalized name and a dot before them. That's the class name. So when we see math.pow, math is the name of the class, and we are connecting it with the method name by that dot. The method name follows the same rules for variable names and use camel casing style or camel hump style. And then methods are always followed by a set of parentheses. They can be empty, but if we have to send information to a method in order for the method to do its job, the values we're sending will go inside those parentheses. Flowchart of calling a method. In this example, our main method is calling the math.pow method. And when it calls the math.pow method, Java sends control over to the math.pow method, and it does its does whatever it's going to do, and then sends its result back. Meanwhile, the main method, it's just kind of pausing while the math.pow method does its job. And then it will resume as soon as it gets that value back from math.pow. And keep in mind, all of this happens so incredibly fast that our brains can't process it that quickly, but that's exactly what's going on. We are passing 2 arguments to math.pow so it can do its job. We're passing 2 and 3. And then what the pow method does is it raises the base 2 to the power of the exponent, which is 3. And then returns the result, which would be 8. And then that will be stored in result, as you can see in the code in the gray square. So arguments and return values. Main passes 2 arguments, 2 and 3, to math.pow. Math.pow calculates and returns a value of 8 to main, and then main stores the return value in the variable result. If we didn't store the return value, if we had math.pow on a line all by itself, that'd be fine. But what would be the point of calling math.pow? Because it would return 8 and we would do nothing with it. We would just ignore it. Here's another example of the black box analogy. With your thermostat, you can set a desired temperature and the heater or air conditioner will automatically turn on. We don't have to know how it works. In fact, few people who use thermostats are HVAC technicians or electrical engineers, and so it's a black box to us. And how does it know the current temperature? How does it know what signals um, it sends back to the AC? It just works like a black box. So we use methods like black boxes. We pass the information the method needs to do its job. In the case of the thermostat, we set the temperature, and then we receive the answer in the case of the thermostat, whatever the temperature is. Implementing methods. Implementing is a $3 word that means code. So coding methods, how do you write the methods? Assume you want to write a method to calculate the volume of a cube. What will that method need to do its job? And what does it do with the answer? When declaring a method, you provide a method name, a variable for each argument, and a data type for the result. So assume we pick a name for this method and call it cube volume because we want to calculate the volume of a cube. We declare a variable for each incoming parameter. So in this case, we only need one parameter, a side length, and that's double. The data type in this case will be double. And then we specify the return type. If the argument is double and we're doing a calculation with it, 99% of the time the return value is going to be double as well. And then we add the modifiers such as public, static. In Chapter 8, we're going to learn something a little different from public and static, but until we get there, all our methods will use the public static modifiers. So inside the box, we have to write the code to enable the method to work. So to calculate cube volume, we enclose it in braces that denote the beginning and the end of the method. We're going to declare a variable called volume and set it equal to side length times side length times side length. And then on the next line, we return volume. So whatever we calculate, we then return. When we come back from the black box, we have to do something with that value that is returned. And note in this code example that we have double result 1 equals cube volume, 2. So we're calling the cube volume method, sending it the side length of 2. It calculates the volume of the cube, sends the result back, and it is stored in result 1. Similarly with result 2 on the next line.